Hello everyone. So welcome to my video. So in this video, we'll have a practical demo session of using Libev APIs. It's a part of Libev library. Okay. So we'll have a one-shot timer using Libev. We have repeated timers using Libev, repeating timer with timeout using Libev, and maintaining the additional timers paid in the structure. Okay, so these all things will cover in this single demo session. So at the end of this session, you will understand how to use the APIs within your program using LibAB. So let's start with the program directly. So I have a timer demo here. Okay. So first of all, I need to include the header file for EV. Okay. So the first API that I will be using here, that is EV underscore run. Simple. And we have a macro EV default. So I will be taking the default timer and comma, and we have zero. That's all. So this will create a loop. Okay. So this program won't do anything. This is just to check the dependencies of this API with the library. Okay, so as told in the last session that we have to install libev dev. So I have already installed here. So if you do sudo apt get install libev dev, and if you try to launch it, so libevdb is already a newer version. I already have this library. So what I need to do is gcc hyphen o my app. I'll give the name of that binary, and I have a timer demo here. Simple as that. When I enter this, it will give me uh, problem in EV default loop, undefined reference to this, and the problem is EV run. So these APIs are not been resolved. So what I do here, I'll add a library externally. So I'll link this library to this program. So when I enter this, it got resolved. Okay. So I got the binary, my app here. Simple as that. And if I run it, I won't get anything. So this lib EV runs on the concept of the watcher, which well watches for the event. So once the event loop has no remaining watchers, it stops. So EV default is the shorthand of use a default event loop, and you should actually be allocating some event loop externally, right, and destroying it at the end of the program. So let's see how it looks like. So now, in spite of using the default loop, I'll create my own loop. Okay. So how to create my own loop so that I can amend the data within that. So one more important thing to check here in Leap EV API is that it is using the ePOL internally at the backend. Okay. So now what I will do, I have a structure that is EV underscore loop, comma, then we have a main loop, EV loop news. So these are the core APIs that we discussed in the last video. Okay, so I created a loop externally, and now I will put this inside. So in spite of using EV default, I will be using main loop now. Okay, everything remains the same. And at the end of this program, I will do destroy, because this won't be automatically destroyed. Okay, so we need to acceptably destroy this main loop. So main loop. Okay. So if I save it and run it, it will also compile, and I got nothing here as well because I just created a loop. I have not input any watches or the timers to this uh, EV run. Okay, so this is an empty loop. just as that with no watcher, mapped to this loop. So now next is I will create a one shot timer now. Okay. So for that, I'll create a function for that is called a timer function. So void run later. Okay. And in here, what I will do, this function will have struct ev underscore loop star main loop comma ev underscore timer, and this is a watcher. Okay. So I'll explain all these terms. Constant events. Okay, and inside what I will do, I'll just do a printf later. Okay, simple as that. So I created a function now. Now I have to map this API to our main loop. So how to do this? So first I need to initialize a timer. So for that I use the API ev underscore timer. Okay. Now I need to use an API ev init now, and sorry, the timer init, because I'm using the timer here. And what are the inputs of this init? I'll have a timer here, and I will map this run later API to this callback here. So I will give this way, then 1.0 and comma 0.0. So this I will explain later. So I just initialize and map my function to this timer init. Okay, so this timer we placed here. And next is I need to start this timer. So ev underscore timer underscore start. And for that, I need the main loop where I need to map comma address of timer. Okay, so this will start our timer as it is mapped to the main loop, and last we are destroying it. So this will wait for 1 second, and then it will come out of that loop. Okay, so here we have 1 second timeout here. So if I increase it to 2, let's say, so 2 seconds will wait. After that, it will print later and come out. So let's compile it, the one shot timer example. So here I compile it. Now once I have to wait for 2 seconds. After that, later comes and your program exited properly. Okay, so it's not been re-registered. Okay, only one shot. After 2 seconds, it come out of the loop. Okay, so next is how to repeat this message with some timeout. So this is our next example. So I'll edit the same thing here. Okay. So for that, for repeating timers, I will change it. I'll change the output and I will say here, for example, repeated or repeat called percentage f. Okay. And here I will do ev underscore now, that will take the timestamp from the main loop and print here. Simple as that. Okay. So now if I change this timer to repeat timer, or I'll do repeat watcher, but this will be watching the timeouts. So I have this repeat watchers here. Run later is fine. And here we have again the repeat watchers. This I changed to make you more understandable. Okay. Now for timeout, if I need to run this API, the timeout of 3 seconds, every 3 seconds. Okay. So what I will do, I'll put 3 and 1 here. So it will run repeatedly after 3 seconds, and you will see that time, uh, this time delay in here. So if I save here and now I compile it again and now I change. So after 3 seconds, you have to wait, repeat called, and after that, 1 second. Here, what we have is 3.0. So initially, it will wait for 3 seconds, and after that, after a delay of 1 second, it will be printing this repeat called thing. Okay. So if I do this and compile it again, and now if I say, so first thing when I enter, it should wait for 3 seconds. After that, after 1 second delay of time, it will be printing timestamp. So 3 second wait. Okay, now if you see only 1 second, it got the delay, and now it's printing the timeouts. So next thing is, as we used the repeated timers that will repeat itself after a few seconds. So now the next example we'll take is repeated timers with timeouts. For example, this thing is repeating, and we have some time. At that time, we need to stop this timer externally. And now, what I need to do? Okay. So for that, I need two APIs. First, that repeat tick. Okay. So that will be repeating this. Okay. So I'll change it here only, right? So in spite of using this, what I will use repeat underscore on tick. So this is the API, and this repeat called, I'll put it here only. And then I just take another timeout run. So we have timeout underscore run, and inside this, what I will put printf timeout reached. Okay, and then shutting down. Okay, next is, okay, that's fine. I think for now it's fine. So I'll add this thing in the main loop. So for that, what I need two timers. What is one is repeat watcher and second is timeout watcher. So I'll put timeout watcher. Okay, so we have two watchers now. First we'll check this repeat tick, and second we'll check the timeout run. Okay, so now I have to initialize these two. So this initialization will be two types. So first is the repeat watcher, same as before. So what I do, without taking much time, I will be running this repeat watcher at 1 second delay. Now the second is timeout watcher. So this thing I also initialize and I will just copy here, and in spite of using this function, we will be using timeout run here, and it will wait for 3 seconds, and then it will stop. So there is only 3 second delay. After that, it's not repeating this watcher. But this repeated watcher, this will be repeating for 1 second. Okay. So let's see how it works first. So I'll save it. I compile it. I got run later. Okay. So where is run later? Here. So we'll change it. We'll take repeat on tick here. And now I save it. If I compile it again and run it, so our on click is running, but our second timer, that is, so now I can see my on tick API is being called for every 1 second, but our 3 second timer is not been called. So let's see why it happens. So if you check here, we have 2 inits and one start. So the main loop only have this repeat watcher. Okay. So we haven't put timeout watcher here. So if I need to add it, so I'll add it like this. So I need to copy this timeout watcher here, add this into the main loop so that our main loop will watch this uh, watcher as well. Okay. So if I save it and compile it, then if I run it, you will see after 3 seconds your timeout reach shutdown. This thing is being called again, but your on click timer, this thing is running for 1 second only. It's not been stopped. So what if I need to create a timeout, so that your timeout watcher will trigger this repeat watcher to stop, and you will stop the full app. Okay, so what do you mean by that? So after this 3 second of timeout, my timeout run will trigger this repeat on tick to stop, and it will shut down after that. Okay, so how to do this? So for that, what I need to do, I need to add AI here, that is EV underscore timer start repeat watcher is equal to EV user data main loop. Okay, and then what I need to do, EV underscore timer underscore stop, and what I need to do is main loop repeat watcher. Also, I need to add EV set user data, that will be main loop, and we have the address of repeat underscore watcher. So what it does, it will save the global things from this repeat watcher to the main loop so that I can access it here using EV user data main loop, and we'll get the watcher data, and then we can stop that timer. Okay. So let's save it. CC hyphen oh my data and hyphen LE. So once I compile it and I will run this thing, and after 3 seconds you will get a timeout and your process is also shutting down at that moment. So this is all about this video. See you in the next session. Thanks.